We have been learning about linear motion. Linear motion is a motion which happens in a straight line. Okay, so whenever we are talking about a linear motion, a straight line motion, we have distance, we have displacement, we have initial velocity, final velocity, acceleration, times. These all were my variables when we were talking about linear motion. Now in this section we're gonna start with a special type of motion which is called as circular motion. Now when we talk about circular motion, let's first try to understand what is circular motion, and then there are few words that we need to know before we dive deep into the circular motion part. So it's very simple. The word circular must have given you an idea what is a circular motion, but when we want to like specifically talk about it, we say like any body. You take any body which is performing a motion on a circumference of a circle. So there is circumference of a circle. So any body which is performing a motion on a circumference of a circle will be, that motion will be called as circular motion. So let's suppose that I have a circle and I take a body with mass m, and if this body is performing a motion, it can perform anti-clockwise or clockwise, it depends, whatever the direction of velocity is. The motion of this body is called as circular motion. Now this is the basic idea of a circular motion. So the body has to be on the circumference of a circle. Now if it wobbles back forth, if it goes here there, that won't be a circular motion. It has to stick to this circumference of the circle. Now what happens is that before going ahead with circular motion, there are a few words, and the first thing that we need to know about is something called as period, or which is related to periodic motion. Okay, now we need to know about what is periodic motion, what is period. This is sometimes also called as time period. So in a simple sense, when we talk about time period or period, it is related to a periodic motion. Now what is periodic motion? Any motion which repeats itself. So if you take any motion on this whole universe, whole world, even around you, you will find periodic motion. It has to repeat itself at an equal interval of time. That's a periodic motion. So equal interval of time is important. So it repeats at an equal interval of time. For an example, very simple example, when we talk about your clock. So if I have a clock, okay, I have a clock. In a clock, I know that if this hour hand is at 1 o'clock, it will come back again at 1 o'clock after 12 hours. After again 12 hours, it will be again on the same. After again 12 hours, it will. So it is repeating itself again and again and again at equal interval of time, that is 12 hours. Okay, so this is called as periodic motion. And once we know periodic motion, we can talk about time period. So time period, as I said, is connected to periodic motion. It is a time taken to complete one set of motion. One set. Now when I say one set, what do you mean by one set? It starts at that position and come back again to that position. That is one set. So first of all, the motion has to be periodic. If it is periodic, then we can connect it to this part, and then this one set comes into the picture. So in this example, this hour hand has a time period which is indicated by capital T of 12 hour. Obviously your 12 hour is not an SI unit, so we'll represent it into second. So 12 into 60 minutes into 60 seconds. Is it correct or not? Let me know. So 12 into 60 into 60. Yeah. So that's how many second is the time period of it. Another example, you can take any example that you want. You just have to see that the motion that you're seeing, it is repeating itself at an equal interval, that is a periodic motion, and then just look at it, how much time it takes to complete one set. That time is called as time period. Now let's, once we know what is time period, let's come back to circular motion. So now we know that there is something called as linear motion that we have been learning, and then one thing we know is circular motion. Now why I'm comparing these two? Because they have a little bit of similarity. When I say similarity, since both of them are motion, when we are talking about motion, obviously they will have some constant common variable. Now first thing, we know that if it is a motion, we have to consider time, and time is time anywhere you go. Time doesn't have any other way of writing it. So time is one of the variable which is common. Then we have displacement. So we have normal displacement, which is called as S. Here, instead of a normal displacement, since it's a circular motion, we have something called as angular displacement. Now what is angular displacement? We'll come to it in some time. We have velocity. Here, as you guessed correctly, angular velocity, which is denoted by omega. Here we have acceleration. Here, angular acceleration. Now this angular acceleration is not part of the specification, but since I was doing the comparison, I wanted to do this, so you don't have to worry about it, that what is this angular acceleration. It's not part of the specification. We will not be focusing on this much, but we know that this velocity is nothing but rate of change of displacement. How much displacement is happening per unit time? That means this angular velocity should be equal to rate of change of angular displacement, that is delta theta by delta t. Here acceleration was a rate of change of velocity. That means here this angular acceleration should be rate of change of angular velocity, as simple as that. So this is how the circular motion, linear motion is connected. Apart from that, we also have an equations which are connecting these three variables to each other. Now let's talk about angular displacement first. So let's consider a circle, and there is a body which is this circle. Let's first say that the circle has a radius of r, and this body is at point A. After certain time, the body goes to point B. When this body is going to point B, it is covering some distance, which is obviously not in a straight line. So that becomes a problem for us. So what we do is that we can measure how much angle the body is covering, and this becomes my angular displacement, as simple as that. So when body moves in a circle from one point to another point, and whatever angle it inscribe at the center of that circle is nothing but the angular displacement theta. So here the angular displacement theta is this value, whatever it is. Now it will take some time to reach from point A to point B. Let that time be t. If that time is t, we know that my angular velocity, that is nothing but omega here, will be nothing but change in angular displacement upon change in time. So how much time it takes to inscribe this angle theta is nothing but my angular velocity. Now in this same circle, let's take a special case. Let's say that this is my radius r. Obviously the radius will not change. My body was at position P, and it covered this distance and went to position Q. In this case, let's assume that this diagram is very perfect and the angle made here is 90°. Now we know that the SI unit of angle is not degree, the SI unit of angle is pi. So this is making an angle of pi by 2. So my theta is pi by 2. Now if I know the value of r and I ask you, how much is this length of the arc is? We know that the circumference of the whole circle, let's denote it by some word C, letter C, it's 2 pi r. And this part, if this is angle 90°, it is nothing but 1/4 of it. So can I say my arc length S, let's say that is arc length S. Arc length S is nothing but 2 pi r upon 4, which is nothing but, if I solve it, it turns out to be pi by 2 times r. And when we were initially describing this motion from the point P to Q, we said the theta, the angular displacement, is pi by 2. That means this pi by 2 can be called as angular displacement in this case, and this gives us the first formula of a circular motion, where your arc length is connected to the radius and your angular displacement. So S is equal to theta times r, or r theta. This is the first formula. Now when we talk about circular motion, the other formula that we have for angular velocity. Now angular velocity, we just defined it, that angular velocity is nothing but a rate of change of angular displacement, delta theta upon delta t. This can be made special, and when it is made special, it gives us one more formula. Now here, if my body starts from P and makes a complete circle and comes back at P again, it will form an angle of 2 pi. So my change in angle would be 2 pi. And now if this is a periodic motion, that from P to P becomes one set. So the time to complete one set is called as time period. So time can be written as time period. So this gives me one more formula. Omega is equal to 2 pi by t. And we know that F is equal to 1 upon t. That means your omega can be 2 pi times F. This is another formula. So we have theta. We can figure out angular velocity d theta by dt, very simple. But angular velocity can be 2 pi t, capital T, well t is the time period. And it can be 2 pi f, where f is the frequency. And s, the arc length covered by an object in a circular motion, is given as s is equal to r theta. Apart from that, we can also connect v and omega. Let's take this example of s is equal to theta into r. Now r is something which doesn't change in a circular motion, but delta s and delta theta will change at some point. That means it can also be written as delta s is equal to delta theta into r. If I divide by delta time on both the sides, now we are doing maths, physics is over right now. So delta s, let's divide by delta theta on both the side. I'm not changing anything, same value is divided on both the side. Now this is nothing but rate of change of displacement, that is velocity. This is the rate of change of angular displacement, that is angular velocity. And this gives me another formula, v is equal to r omega. So right now we can see that in a circular motion, displacement becomes angular displacement, velocity becomes angular velocity, time is there. Your angular velocity is nothing but a rate of change of angular displacement. Your angular velocity is also 2 pi upon t, is also 2 pi f, where this is your period or time period and this f is your frequency. And we know that connection of circular motion to linear motion, s is r theta and v is equal to r omega. Now what is this v? Let's talk about this v for a minute and then we can end this section. So right at this moment, if my body is going in this direction, the velocity of this body, linear velocity, will be in this direction. At every point the linear velocity will change, and this linear velocity is v is equal to r omega. This is a tangential velocity also in some cases. We call this as tangential velocity as well. So this is my v, this is r, and if you know omega you can figure out v is equal to r omega. So these are our simple formulas that we have, and if we know these formulas we can deal with circular motion easily.